Hello, sir. My name is Inderjit Singh Garu. This is my CPAN 211 data structure and algorithm final exam presentation. The data structure I selected is the heap, specifically a max heap using Java priority queue. The problem I selected is the lead code 1046, the last stone weight. First, I will explain the max heap, then problem my solution, its complexity, and why the data structure is good choice. So, as you see the tree diagram on on my slide. A heap tree based the data structure. Heap is also a complete binary tree, which means its level are filled from left to right. There are two common types: min heap and max heap. In a max heap, the parent value is greater than or equal to its children. Because of this, the largest value is always at the root. In my diagram, 8 is the largest value, so it is at the top. A priority queue process element according to their priority. For my problem, largest stone weight have higher priority. The main operations are insertion using offer, which takes 0 log, and removal using poll, which also takes 0 log, and peak, which takes 0 of 1, and searching for a particular value, which takes 0 of n. This uh, Now we go to slide 3. So now I'll explain the last stone weight problem. We are given an array containing different stone weight. During each round, we select two heavier stones. If both stones have the same weight, both are destroyed. If their weight are different, the lighter stone is destroyed, and the heavier stone become the difference between the two weights. We repeat the process until 0 or 1 stone remains. In this example, uh, our input is uh, 274181, and the expected output is 1. Now going to fourth slide. Uh, Here we can see the process step by step. We start with the 274181 and 1. The two heaviest stones are 8 and 7. Their difference is 1. So the stone of weight 1 goes back into the collection. Next two largest stones 4 and 2. Their difference is 2. Then two stones of weight 1 are equal, so the both destroyed. Finally, only one stone of weight 1 remains. Therefore, the answer is 1. Here is the final answer. This process shows why max heap is useful. Every step needs the two largest value. Now we are going to that means I show the code. So firstly, the priority queue integer here from line 10. Here you can see. So it demonstrate my Java implementation. First, I create my priority queue of integers. Java's priority queue normally prioritize smaller values, so I use collections dot reverse order to make it behave as max heap. This means the largest stone will have the highest priority. Now here is the loop of for and while, where here I use a for loop to insert every stone into max heap using the offer method. Next here is the while. The while loop continues as long as the least two stones remain. I call pool two times because this is a max heap. These two values are the two heaviest stones currently available. Now here is the if from line 27. So if the two weights are different, I calculate their difference and insert the result back into the max heap. If they are equal, nothing needs to inserted because both stones are destroyed. Now finally, we return after the loop. If the heap is empty, I return 0. Otherwise, I return the weight of the final remaining stone. Now, I'm gonna run the program. So here it shows inputs of 274181 and the last stone weight 1. So we can see that the input is 274181 and my program returns a last stone weight of 1. This matches the expected answer for the example. Now we are returning to slide 5. This is a justification why I choose the max heap for this problem. The problem is repeatedly require the two largest value. Max heap is a good choice because the largest element is always available at the top. Pool removes the highest priority element in zero log n time, and new stone weights can also be inserted efficiently. Another possible approach would be repeatedly sorting the stones, but that would do unnecessary sorting after each round. The heap efficiently maintain the priority as value are removed and inserted. The overall time complexity of my solution is 0 of n log n. The space complexity of 0 of n because the max heap may contain all of the stone weight. Therefore, the max heap is a natural and efficient choice for this problem. Now, we are going for conclusion. To conclude, the max heap efficiently manage the stone weight because it gives quick access to the heaviest stone. Using Java priority queue allows efficient insertion and removal. And for our example, the final answer is 1. The source I used were the official leak code page for the problem 1046, the last stone weight, and the Oracle Java documentation for the priority queue. Or so we can open the link so we can see the last stone, 10 last stone, the stones and the output, and seeing the Oracle documentation. So here is the all Oracle documentation. So that's all from my side. Thank you for watching my presentation.